presentation. He will talk about exfiltration, which is an interesting word. Good afternoon. Well, we will continue talking about Wi-Fi, which is a continuation of Miguel's talk. So I'd like to link that with APTs, which are kind of trendy now. So you all know what APTs are. It's a persistent threat. It is a malware that it is targeted at people, organizations, entities. They have a capacity for infiltration. It tries to pass unnoticed. It tries to stay in a system for some time, and it is widely used for spying. So why do we use APTs, or why do we refer as APTs instead of malware? Well, because of covered channels of communication. Well, they are also good to extract data without leaving any traces, being silent, being undetectable, and well, that's the essence of them. So whenever we get bored, we devote, well, time to whatever it takes. Okay, some people do drones, we do APTs. What are the different channels of infections that could be used? We have three different groups: the passive one, the active one, and the external ones. So we may have USB memories, or I don't know, infected files. As Microsoft people told us, vulnerabilities through Adobe, and well, and also software, a device that may be deployed on our machine may discover the network in a passive or active manner, and then to jump off and may skip to other or jump to other machines. Well, often this is done through attachments, Word attachments, Excels, social engineering, PDFs. So that's one of the main ways that we use for our APTs. Who uses APTs? Well, there are three major groups. The first one are mafias, criminals, mercenary hearts. I'm sure some of them are present here. The objective is to steal information and to monetize the development of APT to steal money, bitcoins, well, access to the accounts of the company. Second major group, also represented here. Hello, how are you? Government agencies, agencies with acronyms, the military, they also use APTs in their operations, even if they say no. Well, I never ask them so, but if you ask them, well, see what they answer. And then the third group are companies. Companies use APTs in two ways: either by companies who hire mafias or hackers to do industrial spying and to steal research and development information from these competitors, or people who hire security experts such as yourselves in order for them to assess the level of security of their company. These are pen testers. Recent example: Stuxnet, Duku, Flame, Red October, Carito, Icefog, and ours, which is known Acarus. Have you? Well, it is the first time that you hear about it, isn't it? So what is the use that we can give to it as a security analyst to an APT of intrusion? Well, there are many similarities when it to well, through using APTs, we will be able to select objective, to see the mechanisms of security of a person, of a company, to protect themselves against possible attacks from APTs. Also to retrieve data, also to evaluate, well, the workings of different monitoring systems to detect anomalies or abnormalities. So if we are not monitoring, if we don't know what we want to look for, well, we are very likely not to notice that we have an APT in our system. So therefore, the situation becomes a bit complicated. So for instance, capacities of a basic APT. So channels of communication to filtrate or take control of a system, direct communications via TCP, UDP, through HTTPs, through other platforms or websites that are well known to us. DNSs. No one filters through DNSs in organizations. Probably domain controllers may use that to resolve external problems, and through this channel we may infiltrate data, and then communications with APT should be encrypted so that those who are looking for patterns or data cannot find them. So we are talking about SSL, TLS, CBS. Some people filter through base 64, and the third characteristic of an APT is persistence and camouflage. Should deploy itself in a machine, stays there, remains silent up until it receives the call from the control center. What can go wrong? Well, we may not be able to take control of the machine because the company has good security measures in place, or the machine is isolated from the network, or I don't know, DLP policies, firewalls, or just because the machine is not connected to an active network. So we said, okay, let us try to find an alternative channel that we can use so that we can retrieve information from a machine. After looking at the state of the art and to give some thought to it, we came out with different possibilities. We said, okay, we can use the camera and we can send out a Morse coding, or we can use the same technique that bad BIOS. It is so secure, no one has ever seen it. Or we could use Bluetooth. Considering the new standards, well, the distance that is covered was okay, was appropriate, but we didn't really like it. And then if NSA says that it can take control of a machine in 15 kilometers, I say, well, if we use a big antenna, we can also do so. Actually, the technique that I will share with you is not fully new. It is not brand new. 3 years ago, as far as I know, people from core security talked about using WLAN API, native API from Windows, to infiltrate information. However, it all stayed in a theoretical paper. There was no proof of concept. So we decided to go beyond that, and we developed a client-server application. The client on Windows uses the WLAN API that allows us to see the networks available to us, networks around us, and it also allows us to ask the rest of the devices around us whether a network is available, whether we can log on. So WLAN API allows us to do asynchronous reading, and we are also able to issue proof request packages onto the air so that someone listens to us. The server of our APT control center has a system that writes and reads raw packets. Well, we like Windows very much, and out of simplicity, we decided to use it or to develop it on Windows. And then we also added, or we also used like big antenna. The generic operation of this thing is very generic. We have an infected machine. It sends out packets in the air. The command and control center, whenever it is within reach, responds. I say, yes, I am there. The infected machine asks, what do you want me to do? And I say, give me a shell. And then the machine executes a shell, and then through Wi-Fi packages, and then the command and control sends out the standard entry through a cycle, okay? And as long as the connection is active, well, we can continue interacting with the machine. What name have we given to that? WXP, Wireless Exfiltration Protocol. It is simpler than HTTP, and it allows us to expose an interface to a software upstream to establish a two-way communication in an asynchronous manner. So trying to emulate, to mimic TCP/IP. So there is a three-way handshake, and we can also manage asynchronous connection. WXP will manage the forwarding of packets, management of lost packets, tell the other end the packages or the packets that have been received, etc. The snapshot of WXP is the following. On top we have Acres, our APT, and that APT communicates downstream to different interfaces, and in this case it communicates through WXP. It does infiltration through Wi-Fi. Acres does calls to read and to write data through a stable channel, and then we connect with the other end, which is a machine or equipment with an interface, and then it will rearrange the packets and it will give us connectivity with the machine or with the equipment through Wi-Fi. The IP is very simple. In it, to initialize the system, connect, listen, read, write, and close. By the time we have finished, to transfer all data from the remote machine. Well, not to confuse you a lot, and for you to understand what this is all about, let me show you the first demo. Two consoles, two equipments. We execute ipconfig. This machine is not connected to the network. This machine hasn't got an IP address. It's a different machine. Then we initiate our APT, and then we execute by monitoring raw packets. So we execute a software that will interact with a command and control. When both in the middle are detected, we send a request to APT for it to execute a shell, a console. Then exchange of messages starts. Messages may be disarranged or not in order, so looking like not flowing communication. On top we have shell. It uses Wi-Fi remote packets. We have ipconfig on the remote machine. We start to see the arrival of packets, confirmation of those packets. Well, could be more or less interactive, but sometimes because of the functionalities that we included may be a bit slowed down, okay? This is an example of execution of a console of a machine with no IP address, isolated by using its native Wi-Fi cards. We can take control of the machine. WXP is a communication protocol, same as TCP/IP. And for that we have our PDU, Packet Data Unit. This is the internal structure to manage and to rearrange the two packets that has been exchanged between the two ends. So 16 bytes included within the packets that we sent from our CNC center. And then the different elements that we will find on PDI are session ID. TCP uses the port to establish connection between two equipments. It doesn't really make sense to talk about ports for this protocol, so therefore we use a random name that is negotiated between the two parties. There are different messages, SYNC, SYNAC, ACK, repeat packages to ask the other end to send us back a packet that we didn't read, and then, like reset messages. We have a scramble. We have some bytes that help us differentiate duplicated packets due to repetition or because the W of the API is sending out the same packets in several occasions. We also use a sequence number. Every time we send out a data packet or a reset, we increase this counter so that the other end knows that the packet has been received rightly. Then we also have confirmation queues to tell the other end, to acknowledge to the other end that we have received the packets. And then, well, we count the number of packets that were received. Session ID to identify the session between the two ends. And then a checksum to check the summation or the total number of packets. Well, this connection is so simple. All of you know it. We have a team machine that does XP connect. Then a SIM packet is sent out, and then connection takes place, and then we notify it to the other end through ACK. It is plain, simple, elegant, and we are not inventing anything new. WXP uses 5 tails. We have one which is known as inputs. That is to say, these are the packets that are waiting to be sent to the APT. So if APT does a call to read, will be on that queue. Then we have output. These are packets that are ready to be sent out through Wi-Fi signaling messages. We have an incoming queue. So as we receive packets from the other end, and if they are not arranged, we keep them there up until we have time to arrange them, to put them in order. Then outcoming packets that have been received but not acknowledged as received, and acts queue with a sequence number that we will be confirming to the other end. Other than having different queues, we have different threads, different processes that interact with these queues of messages. We have a timer. Every so often reports through ACK messages to the other end that the packet has been properly or rightly received. So here we will be receiving packets out of order, and then we will notify to the other end the packets that were not in order and that you couldn't read. We also have a timer for lost packets. We will also communicate that we will call the other end to let it know, and then another thread that it will move the packets from incoming to outcoming once the packets have been arranged in order. An example of transmission with WXP, we have one of the machines with sequence number 2, sequence number 5, sequence number 1. They will not be in order because the transmission means that IP or Wi-Fi API gives us is a collateral effect. After some timeouts, we will be reading the queue of messages, and then we will communicate to the other end that we have received the packets 1, 2, and 5. Same as in the previous example. Right, so we can see that this is not a legal Windows version. Again, console infected, ATP control center. And then we will ask one of the machines to transfer a file to us so that we can really measure the performance of the channel of communication. Right, well, I should have shown the RootedCon logotype, but it was not. We have the communication between two settings. Now the API is sending out data from a file that we want to infiltrate to the other setting, to the other end, and the system periodically will start to receive all the messages. Some of them will not be arranged in order, some of them will be lost. The other end will receive a message about the packets that have been lost, and then, well, this is a test image, and then once we have this test image, we send it out to the other machine. Right, it is not very fast, isn't it? Right, zero 0.9 Ks per second. We have received this bin file. We received it successfully through Wi-Fi. Thank you.
Velocidad de transmisión a través de este canal completamente...
Transmission speed through this strange and asynchronous channel that we have set up, well, it's a moderate speed, between 1 and 3 Ks per second. Well, considering the modeling of the protocol, it seems that the SIM is not fully interactive because we will be receiving, well, some packets and we will not see them all after some time. The transmission could be, or the transmission speed could be changed. And I'll show you right now how to do that. How can you detect an APT, Wi-Fi APT? That is to say, mainly by abnormalities, same as we detect any other APT on cable. Well, in this case, a Wi-Fi APT, which is not a standard, we will see lots of signaling messages, probe requests and probe responses. Many more than typical. So sometimes when the control center sends out a message, the infected message may be for years, months and weeks active, but we will not be able to see it, and we will only be able to detect Wi-Fi APT if we are monitoring the network. Well, sometimes we may also detect it through interferences. Where we were programming WXP, well, our internet connection was crashed. You know, well, because we kind of overloaded the channel. And of course, with acrylic Wi-Fi, we can detect the presence of accuracy and, well, WXP. And to finish off, improvements, changes that we will introduce or reapply to WXP. This is a secure transmission mechanism to exfiltrate data. Once a machine is infected, we have, well, let's say that we have taken control. Sounds better than it is infected. We can use WXP to install a native driver so that it can read and write raw packets. So we are shifting from a transmission speed of 1 or 2 Ks per second, and then, well, we can send out malformed packets, and then we will have our own signaling pathway. So we will be adding channels. If you have 5 cards in ACKs, we will have that also in the future and with big antenna. So we want to do transmission to Linux, to DT, WRT, Android, etc. And in terms of optimizing the protocol, we want to include queues and grouping of PDUs. So we also want to introduce loads of data within the packets so that we can take like 3 times as advantage of the bandwidth of the channel of communication. Well, it will not be only a proof of concepts. Next week, Sunday or Monday, we will release the full code of WXP. I can think about very many bad reasons to use it and not about so many good reasons. Well, we've been talking about proof of concepts of this kind for a long time now, so I think it is important for all of us to assess it and to think about protection mechanism. You can use this WXP to include it in your APT and then want to use it to infiltrate data. So let me thank everyone from TarLogic for their effort and their work, and to Batch Drake. Okay, he has made this system a fully functional one. Thank you. Are there any questions? Hello, Andrés. Congratulations for your for your presentation. I wish you never do an APT to me. Right. My question is, why? Response? Well, don't you have any other packet that allows you to introduce more data? Well, API that we have on Windows to interact with Wi-Fi networks allows you to see the available Wi-Fi networks around you. So they go through peak or through response. So it allows us to tell us whether a hidden network is around us. And the way to know it is by sending a probe request packet. So the only way to interact with the Wi-Fi medium is through this API and through this type of messages, the probe request. That's why we encapsulate within these packets information elements. So some tags within the packet, and then that's where we load all the data. Well, I'm trying to negotiate a web key. Well, would you have like bigger space in the packet? Our objective was to be able to establish control, no, to take control of a machine that it is connected to another Wi-Fi network. So we really want, even if the equipment is not connected to the network, we really want to take control of the machine. That was our objective. Hello, Andres. Wonderful presentation, as always, and that you released, that you published the code. It's wonderful. Thank you so much. We really want, well, we appreciate that you help very many people learn from that. Well, you mentioned about good uses. Well, I'm interested in finding out about the good use. Well, it is obvious about the bad reasons to use it. Well, what are the possible good applications or good use of that? Well, it is about programming or developing systems to detect abnormalities in Wi-Fi networks. Last year, we talked about the use of APTs through Wi-Fi. We are not giving enough importance to them. Well, this is a technique that has been out there for a long time, but no one has released the code so far. By making it available to the community, we will be able to develop this kind of things that I've just mentioned. Wonderful presentation, impressive, yours and your brothers. So the first thing that I could see as I was listening, well, I was thinking about the bandwidth, but what about the encryption? So we have a Wi-Fi deciphered channel of communication. Well, joking apart, WXP, it is a transmission protocol. So the encryption is on the top layer. So the APT write call will encrypt with the mechanism that it chooses. But when you will release the code, the protocol will be detectable. So you are killing it. My question is, have you been offered money for that? Now and again, we get bored Sometimes we mount hardware. Sometimes we play around with AVs. So we decided to develop something that we found interesting and, well, that it fitted perfectly right with our philosophy.